Welcome viewers, in this video we will see the solved problem based on the slip of three-phase induction motor part 1. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the first problem. A slip ring induction motor runs at 290 rpm at full load when connected to a 50 Hz supply. Determine the number of pole and slip. Synchronous speed is 300 rpm. So first we will analyze the data. The synchronous speed is given as 300 rpm. But the motor rotates at 290 rpm at the full load. The frequency is 50 Hz. We need to find the number of poles and slip of the induction motor. First we will find the synchronous speed. The formula for synchronous speed is ns equal to 120 f by p. So in this synchronous speed is given, frequency also given, so that we can easily calculate the number of poles. So by interchanging these two parameters, p equal to 120 f divided by ns. This p is brought to numerator, n is brought to the denominator, so that we got the expression for pole 120 f by p. So that is equal to 120 into the frequency is 50, the synchronous speed is 300. So by simplifying this, we got p equal to 20, number of poles equal to 20. Now we will go to the slip of the induction motor. The slip of the induction motor, the formula S equal to ns minus n divided by ns. That is the difference between the synchronous speed and the rotor speed divided by synchronous speed, right? So the synchronous speed is given as 300. The speed of the rotor at full load is 290. So 300 minus 290 divided by ns, 300. So by simplifying this, what we got, 0.0333. So while getting the percentage, it is around 3.33 percentage. So we calculated number of poles as well as slip of the induction motor. Now we will go to the second problem. A 12 pole 3-phase alternator driven at 500 rpm supplies power to 8 pole 3-phase induction motor, right? So the 8 pole 3-phase induction motor is available. It is driven by the 12 pole 3-phase alternator, which is rotating at a speed of 500 rpm. If the slip of motor at full load is 3%, the slip of the induction motor is given. Calculate the full load speed of the motor. We need to find the full load speed. Now we will analyze the data. For the alternator, the number of pole is 12, speed is 500 rpm. For induction motor, the number of poles equal to 8. The slip is 3%. 3% mean 0.03. We need to find the speed of the motor. First we will find the frequency of the induction motor from the alternator data. That n equal to 120 f by p. That is a standard formula available. Speed equal to 120 f by p. From that we can find the frequency value. This n and p is multiplied and 120 is brought in the denominator. So that f equal to p into n divided by 120, number of poles and speed divided by 120. This data refers the alternator. Alternator, number of poles and speed is refer the alternator, so that we can get the frequency of the supply. So the number of poles of alternator is 12. The speed is 500 rpm divided by 120. So 12 into 500 divided by 120, it gives 50 Hz. So the supply given to the induction motor is having 50 Hz. Now we can find the synchronous speed, ns. Our final aim is to find the full load speed. Before that we will find the synchronous speed. ns equal to 120 f by p. Same formula, but this one refers the induction motor. This one refers the alternator. Now this one refers the induction motor. So ns equal to 120 f by p, that is equal to 120 into frequency. Frequency just now we calculated 50 Hz divided by number of pole is 8 pole. For induction motor, 3-phase induction motor, number of pole is 8. So by simplifying this, what we got, 750 rpm. The synchronous speed of the The synchronous speed of the induction motor is 750 rpm. So by using the data, we can able to find the full load speed. Full load speed in terms of slip is available this formula, n equal to ns into 1 minus s, because slip is already given, ns also calculated. So by using this formula, we can able to calculate the full load speed of the 3-phase induction motor. So n equal to ns into 1 minus s. ns is 750, just now we calculated, into 1 minus the slip is given 3%, that is 0.03. So by simplifying this, we got n equal to 727.5 rpm. So we calculated the full load speed of the 3-phase induction motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.